This is KXSF 102.5 FM, streaming worldwide at www.kxsf.fm. And you're tuned in to Spark with Kellee Marlowe, informing minds, inspiring ideas, igniting innovation. Let the conversation sink into your soul.
This is Kellee Marlowe, host of Spark. Today I will be talking with Danielle Dixon, who is a marine biologist and associate professor of School of Marine Science and Policy at University of Delaware. Her research and conservation work have been featured in leading media outlets, including BBC, NPR, and National Geographic. We will be talking about how she's using 3D printing to prevent the extinction of coral reefs. Thank you for joining me on Spark today, Danielle.
Thank you for having me.
Can you explain what is happening to the world's coral reefs?
Right now, coral reefs are degrading at an alarming rate. This is happening for a lot of reasons, but some of the main reasons are climate change-induced causes, like temperature rise of sea surface waters, which cause corals to bleach, and then once they bleach, if they don't recover quickly, they can die. So that's more of like a global stressor. But then there's also local stressors of, overfishing, pollution, tourism damage, like standing on corals, things like that. Yeah, so they have an uphill battle right now, basically.
Wow. So it sounds like there are a lot of different forces that are putting pressure on them. I do have a quick question about sunscreen. There seems to be discussion about how certain sunscreens are bad for them. Can you talk about that?
Yeah, so what we know is that, and again, it's not really controversial that sunscreen seems to be having negative effects on coral reefs. I think a lot of scientists worry that if we put so much effort on banning certain sunscreens that we're ignoring the fact that climate change is actually a huge issue, and it sort of like makes people feel like they're doing something, but really sunscreen is kind of a minor issue compared to global warming or something like that. But we do know that chemicals that are found in sunscreens can have negative effects on coral growth. It can have negative effects on coral health. I've done some research on sunscreen showing that it actually affects animals substantially, especially when they're in their developmental phase. And my lab is actually trying to identify a safe sunscreen for horseshoe crabs because we're in Delaware, and Delaware is like the hot spot of horseshoe crabs. But to be honest, a lot of the chemicals that are in sunscreen that are negatively impacting coral reefs actually are also negatively impacting humans. So not putting chemicals like oxybenzone or avobenzone on your skin is probably a good thing to stop doing anyway. We know that they're endocrine disruptors, so they do cause problems for people as well.
Interesting. What about the sprays? I always worry about the sprays since the sunscreen's like flying over the place, right? And a lot of people are using the sprays.
Yeah, that's one of my main concerns for the reason in the water. People doing more water research on coral reefs are thinking like you put it on and it kind of comes off of your body and gets on the corals that way. Horseshoe crabs lay their eggs in the sand, like right where they lay their eggs around May and June, and then it becomes high tourism season in Delaware. So then people like spread their towels out, lay on the beach, and spray sunscreen all over the sand. And sunscreen is meant to stick on people, so it sticks on sand too. So yeah, a lot of the sunscreen that you're spraying actually isn't hitting your body, and it's hitting other things. And because it's made to spray and stick to you, it's also spraying and sticking to other stuff. So if people want to make a change in the sunscreen realm of stuff you could do to help save the planet, I would say put as many UV-proof clothes on you rather than sunscreen on you. So like, in my family, I have a swimsuit that has long sleeves, and then like I dress my daughter in like a rash guard so that I only put sunscreen on like her face and her hands and her feet instead of her whole body. And then avoiding that spray sunscreen would probably be a good idea. We don't have a lot of empirical data yet showing just like how negative the spray is versus the lotion stuff. But like you said, when you're spraying it, you're inhaling it, it's like going everywhere. So it doesn't really take a lot of it's kind of like common sense that it's going in a lot of places.
Yes. And I think every little bit that we do counts.
For sure. Yeah. And like I said, a lot of the chemicals in sunscreen is bad for you and bad for, your family. So if you think about something that you're all of a sudden aerosolizing and inhaling, that does not seem like something that I'd want in my lungs either. So I'm really particular about the sunscreen that we use as a family, both because I'm concerned about the environment for sure. And I do think, like you said, everything you can do helps. But also, I'm concerned about the chemicals I'm putting on my skin and my child's skin, because your skin is an organ that's super absorbent. So,
and are there particular sunscreens that you recommend versus others?
Yeah. So one thing that we're looking into is some of the natural mineral-based sunscreens, so like the zinc oxide or titanium dioxide. We did find some negative impacts from zinc oxide sunscreens on horseshoe crabs. I think it's because in nature, zinc and titanium are actually pretty rare, even though they're found in nature. They're not found commonly in nature. So having high concentrations of that, like in water, could be bad too. Just because something is natural doesn't make it good. Arsenic is natural. It doesn't make it okay. There is a company called Stream to Sea, and I know that they've done some research on their own. That's the next sunscreen product that we're going to try, but their sunscreen actually has been tested by them on coral larvae, and it seems to not impact the coral larvae, which is kind of the most sensitive coral stage. So I'm really interested in that brand, but it's non-nano titanium dioxide, which basically the size of the particles that titanium is ground to. And that seems to be kind of factor that seems to be benefiting things. Our goal is to identify a safe sunscreen, but we're still kind of in the works on that kind of project.
It's so complicated.
Yeah, it is. It ends up being a lot more like chemistry and physics and stuff than you would initially have thought.
Okay, so going back to the coral reef, what is its role in the marine ecosystem?
Coral reefs play a huge role, I guess I would say, even in the global ecosystem. So coral reefs are found on less than 1/100% of the ocean floor, but they actually house more than 25% of the ocean's animals. So they have you can think about them as New York City on steroids. They have a ton of living creatures on this tiny surface area of reef land, I guess, or bottom land of the ocean. And then because of how compact they are, for places that are coastal and use the reef, a lot of communities use the reef as a food source for fishing and, invertebrates like lobster and urchins and things like that. They also do a lot of coastal protection. So when cyclones or hurricanes are coming close to shore, if there's a reef offshore, the reef makes the water shallower, so it actually weakens the storm system. And then when that storm system hits land, it doesn't hit land as hard. Same with large waves in places that get tsunami waves, or in Fiji they're called lokas. They're not tsunami size, but they're big waves basically. It helps to dissipate the energy. There's also, they play a huge role in terms of they're a good primary producer. So corals are plants and animals, so they're photosynthesizing. They sequester a lot of carbon, which is really important. And then we're just starting to scratch the surface on their role in something like drug discovery. So I was involved in a project that just recently ended, funded by the National Institute of Health, where we were actually looking for novel compounds in the ocean that we could use as potential medicines. We kind of just started looking there, and there could be something like a cure for cancer or something that is hidden in the reef that we just don't know.
Interesting. Can you talk about your innovative 3D print approach to solving this dire state of coral around the world?
So one of the things that we have been really interested in is what we know is as a reef degrading or, having issues, one thing that happens is structural complexity, or the amount of little hidey holes and crevices that fish have available for them. It goes way down. And we know that structural complexity is really important because fish and other organisms play roles. You can think about, go back to the New York City analogy, all of these animals that live on the reef kind of have a job. So there's like herbivores that eat the algae that makes the corals be able to grow and live, or there's animals that kind of scrape rocks and cleans off space for new corals to grow, things like that. If we're fishing those animals out and there aren't small spaces for their little babies to grow up to be big to then do the jobs, we're going to have more problems. For a coral reef, what we're thinking is that we know that as a reef degrades, like think a cyclone comes through or a hurricane or something, the reef gets flattened. And if it gets flattened, it loses a lot of that structure. So our idea was to use 3D print technology where we use something called photogrammetry, and we actually take a bunch of pictures of a coral skeleton, and then we can stitch it together in a computer program and make a 3D model of that coral skeleton, and then we can 3D print that actual coral skeleton. So our 3D prints are actually real corals, but they're just 3D printed instead of being living corals. And then we've done some experiments where we've placed them out on the reef. We place them next to corals, and we're looking at how they would be used as sort of like a FEMA trailer is after a hurricane comes through. You know, the buildings all go away, but to keep people there to do the job and to clean it up and to keep the kind of economy going. Same kind of thing, like these 3D printed corals can be used as temporary houses for fish, and then coral can hopefully grow on top of them, and then they sort of become like scaffolding. And the 3D print filament that we use when we're working and printing is actually made out of a cornstarch, because it was really important to me that we weren't putting plastic out on the reef, because microplastics is another huge issue that I did not want to be contributing to.
So the coral reefs are printed in starch, cornstarch, and I've heard that they've been made in ceramics, so there are different kind of materials that are being applied to this application.
Yeah, some people use ceramics. The problem with ceramics is it tends not to be as strong in terms of like resistant to waves or something like that, whereas the cornstarch filament is much stronger. And then other people have printed in cement. The cement has some like pros and cons too. It can have a really low pH, with ocean acidification being kind of a problem. You also don't want to be putting low pH cement in the water either. So we've done quite a few trials on which filament we think is best. The cornstarch filament seems to be working really well. It doesn't seem to have any negative effects on coral larvae or fish, both behaviorally or survivorship.
But it will break down over time.
Yeah, they will. And we're still doing some research to try and figure out how quickly they'll break down. So I have filaments that are in water under UV lights, like warm water, like reef water, in UV lights that we're periodically testing for structural integrity. And they've been in there for 4 years, and they have yet to lose structural integrity. So they don't break down quickly, which is good because corals grow really slow. So the last thing we want to do is print all these 3D printed corals and make extra homes and then have them break down before the corals had a chance to kind of overgrow it.
Once they're bioprinted, how do you install them and make sure they don't move with the dramatic climate shifts?
Yeah, so we've been using the same technology that people use for coral gardening. So in coral gardening, you basically take a coral and break it into tiny pieces, and then you can use a marine epoxy to secure it to just a bare rock or something along those lines. Experimentally, when we're running experiments, a lot of times we make like a cement plate that we kind of put it in, so that way we're controlling how far apart things are and distance, and we have more control over the experiment. But they definitely hold really well when you just epoxy them to the substrate.
And the marine life moves around it and doesn't really affect the structure at all.
No, I mean, we had recently in the project site that we have in Fiji, we had one of our experiments, we couldn't use it for the experiment anymore because one of the local Fijians put a bunch of broken coral fragments into our 3D printed corals of the experiment, and those broken coral fragments actually overgrew our 3D printed coral and fused to them, which was sort of the end goal of the experiment, but also made that replicate not be usable because we didn't do that ourselves. But like we have found, little tiny coral larvae that have successfully settled on them and started to grow. And then we've videotaped them with remote cameras, and we've seen fish use them. We've seen urchins and brittle stars like kind of live inside of the 3D printed corals. They seem to just integrate pretty quickly.
How long does it take to print and install them?
Takes about, if you have your printer running 24 hours a day, which we tend to do before an experiment, you can print 2 corals per printer per day. They do take quite a bit of time to print. I'm working on some grant proposals right now where I'm trying to utilize the fact that 3D printers are available in a lot of schools so that I can have schools help me print, and then I can do some outreach, and then they're helping to save the reef at the same time, because that was one of our big limitations. Is I have available at University of Delaware, I have 5 3D printers. When you're printing 90 corals before a trip to Fiji, that's actually what's the limiting. We're pretty stressed about, are we going to be able to make it in terms of getting as many corals as we need, because you have to start printing quite a ways away.
I'm sure there are quite a few people who would love to step up and help you.
Oh yeah, I don't have an issue with, for sure. I've talked about this in other venues, and I get contacted right away by schools. So it's more I need to get a funding source to be as excited as the schools are. But I think it'd be really fun to have schools help, and then Skype them when we're in the field, or send a video back to the school where they can see the corals that they printed as a outreach option, and cool way for young kids to be integrated into like real science. It seems like a really viable idea.
Where are they currently installed?
Right now, we've done all of the work in Fiji. So all of our stuff is in Fiji. They're in a marine protected area at one of the local resorts, and the resort was happy for us to keep them there. We talked to them, and they're going to continue to kind of maintain it. So that's sort of the good news, is that depending on what funding comes back, like this could end up being a long-term study where we just go back to Fiji every couple of years and check on what we did. But right now, everything we've done so far has been in Fiji. I'd really like the new project to be based more locally, just to reduce my carbon footprint of not having to travel to Fiji to check on this. If I could just do it on a Florida reef or something, I think that would be a lot easier, more feasible, and reduce the amount of CO2 emissions I'm creating.
So it sounds like the results so far are promising, and that it could be deployed worldwide.
Yeah, I think the results are promising. I still think there's like more research that needs to be done to make sure we're doing it in the most effective way, or that the most cost-effective way. Because so far what we've found is that one thing that I don't think is a good idea is to just make only 3D printed reef. We've been kind of working on finding what's the least amount of filaments that we put out onto the reef that we get the most gain. So we've been mixing where we're putting some live coral and some of our 3D printed filaments on the same area, hoping that the live coral will quickly overgrow 3D printed coral really fast. And then that can help to speed up the recovery too. The complexity of the issues that coral reefs are facing are actually going to take a variety of approaches, where you have like marine protected areas and fishing regulations. And then I think you're also actively doing something like deploying 3D printed corals, or doing coral gardening, or a combination of both.
What can we do to help the preservation and the increase of coral reefs?
I think as cliche as it sounds, there's a lot that just anyone can do. Like you can be my parents living in Minnesota, and you can still do things to help the coral reef. Global warming and climate change are some of the bigger factors that they're impacted by. So things like reducing the amount of red meat that you're consuming, reducing your carbon emissions, eating locally, that kind of stuff would be really helpful. Supporting like ecotourism is always a good thing, where you're putting your money in a place where it's meant for conservation instead of just like tourism, and, like reducing how much plastic you're using. Not like we were talking about before, not putting a ton of sunscreen on, instead just cover your body up, things like that.
Well, these are definitely tangible things that everyone can be doing. Whereas if you ask somebody to take on climate change, it's a little bit more difficult, right? Because no one knows what that means.
Yeah, exactly. And that's where it's like, if you live in a place where you could bike to work, that is a huge help. If you decrease the amount of time you have steak for dinner, that's a huge help. If you plant your own garden or do composting, all of that stuff stuff is helping climate change, and small actions actually make huge differences. That's one of the things I teach in my conservation classes. I have the students kind of pick a thing to do, and a lot of them pick, I'm going to stop using plastic bags and I'm going to bring my own reusable bag to the grocery store. And then the assignment is that they have to calculate how many bags did you save? How much petroleum did you save by not having plastic? How much water did you save by not using these single-use plastic bags? And they're always amazed at how much one person does in like 3 months of the course. It's tiny things that anyone does actually does have a huge impact.
And that's a really good point, because every time I go to the beach, I'm always horrified at how much plastic there is that's going to flow into the water. And it only takes a few people to generate that much plastic that can go in the water.
Yeah, I mean, whenever I go to the beach, I actually bring things to pick up garbage now, because there's just so much trash and like cigarette butts and things like that you're just like, this is just gross, and you know it's going right into the water. And supporting politicians that agree with like green initiatives are always a good thing too. In terms of like plastic bag use or single-use plastic bags, a lot of states are going towards banning them, and they're actually good to ban them for a lot of reasons. Like they get into farming equipment, and then they cause problems with the farmers. Like it's not just like people who love sea turtles that want them banned. You know, it actually has other impacts that would help everyone. And it's really not that big of a deal to bring your own bag. Once you just decide to do it, you just stop forgetting. And it's
yes, and also straws, right?
Yeah, I have a case of silicone straws that I keep in my purse, or I just drink out of a normal cup like I normally would drink out of a cup. Like, I don't know why straws all of a sudden are so necessary for people. You can literally bring stuff with you. I have a set of bamboo cutlery that I also keep in my purse so that if I get takeaway food, I don't have to use plastic forks or knives or anything like that. And it's much nicer to eat off of that instead of like those flimsy plastic forks anyway. So I think there is like a lot of tiny steps that people can do. I think a lot of people don't take them because they either don't know about it or they don't think it makes a big difference, but it really does make a big difference.
I think you made a really good point about bringing your own set of, they have these prepackaged, right? And I said you can have your fork, your spoon, everything you need in one, and you can just carry them everywhere you go. And if you think about how many plastic forks and spoons that you are saving from going into the trash or the environment, it makes a huge difference.
Yeah, over your time if at your job you eat out for lunch and you eat out for lunch at at like a taco truck or something where it's not like sit down lunch or whatever, think of how much of that kind of stuff you generate, and think of how quickly you could just stop generating it by just carrying something with you. It actually does add up quite quickly. And even if you're skeptical, like just do an experiment. Like those little, like the bamboo silverware that I have cost maybe $10, I think, and get it and then count how many times you would be using something, and you'll quickly see that your $10 investment over the course of like a month made a big difference in a month. Now think about it in a year.
Yes, or else we could ban them, right, to stop them from being
Yeah,
used.
I mean, that would be much better, but
yeah, that's going to take a while. Well, I appreciate you joining me on Spark today.
Yeah, thank you so much for having me.